Welcome back, guys. Our primary discussion is going to be on nature of the roots. So now we investigate the nature of the roots using discriminant. So now this is just delta, and the whole formula or the whole equation, it's called the discriminant. I'm sure this is not the first time you see b squared minus 4ac. This is not for the first time you see this part. You learned about that part from the quadratic formula. All over 2a. So there is that part which is the discriminant. So now let's investigate this thing. It's better to investigate it because by investigating it, you get a clear view or a better view of what is the idea behind this thing. So now we want to remember your b squared, remember your b, your a, and your c. You can't get them if the equation is not in the standard form. Guys, you must always remember, if we get this equation, we need our child. So by our child, 49 need to go so that we can see our child. So now we have x squared. What do you do with the 49? You take it to the other side. So minus 49 equal 0. Beautiful, beautiful. There is our child. So now we can start by identifying what is our A, what is our B, and what is our C. So now, comparing the standard form with the equation here, it's visible that the value of A is 1. And then what about the value of B? Do you have X here? No, we don't have X. So now what is the value of B? That's 0 because we don't have the X part. And now what about C? Do we have a constant or a number? Yes, take it with its sign. That's negative 49. Beautiful. So now with these values, we want to investigate the nature of the roots of this curve, which is x squared minus 49. This is just a parabolic function. So now we want to see if it has roots or what. And by roots, we're just referring to the x values where the curve intersect with the x-axis. So now that's what we want to investigate, whether it cuts the x-axis or it does not cut the x-axis. And then if it cuts with rational values or irrational values. So that's what we are going to investigate. So it's better to get the standard form and get our child, get the value of A, B, and C, and then substitute into the discriminant formula to see what we will find. So now the discriminant formula is delta equal b squared minus 4ac. This is the formula that we use to investigate the nature of the roots. So now, what is our b? We got it there. Nice. That's 0 squared. Put everything in brackets when you substitute. Minus 4. What is a? It's 1. What is c? It's negative 49. So now I will just put the answer here. Now we get our calculator. We can calculate this thing with our heads, guys. So now we put everything in a calculator. We have 0 squared minus 4. What is a? It's 1. What is c? It's negative 49. So what is the answer? It's 196. So now what I want you to do is take the square root of 196. Now, okay, we can just say the square root of 196 and we look at the answer closely. 196 equal sign. We get a beautiful number. The answer is 14. So now let's look at the answer. The answer is 14. The first thing that we check, is it positive or negative? The answer is positive. So now if the answer is positive, we start by saying the roots are real. Why are we saying the roots are real? Because the discriminant is greater than 0. If the discriminant is greater than 0, the roots are real. So now let's check. If we put the discriminant under the square root, the answer is a perfect number, which is 14. So now what we say is the roots are real and they are also rational. Why? Because the square root of the discriminant give us a real or gave us a natural, can give us a real number or give us an exact value. Simple recap. We calculated discriminant, finding ABC was our primary goal, and then we found the discriminant to be 196. We found the square root of 196, it was 14, which is exact value. So if we get exact value, we say the roots are real and are rational. The real, we are saying they are real because delta, it's positive, it's greater than 0. We're saying they are rational because if we take the square root of delta, we get exact value. So now let's go to the next one. It's better if you apply them before doing difficult and cumbersome questions. So now let's look at this one. What did I say? I said we need our child. We don't have our child and we need our child. So to get our child, it's x squared plus 2x. And then what do you do with that negative 5? Take it to the other side. So we have plus 5 equal 0. There's our child. Guys, every time I see my child, I think I just need to highlight with the red pen. Even though this red pen is disappointing me, but no problem. So now let's check. What is A? What is B? And then what is C? So what is A? That's 1. What is B? That's 2. What is C? That's 5. Nice. So now let's substitute this into the discriminant because we want to investigate the nature of the roots of this function. So now delta equal b squared minus 4ac. So delta will be, what is your b? That's 2. So you have 2 squared minus 4. What is your a? That's 1. What is your c? That's 5. So now delta is equal to, we go to our calculator to substitute the whole thing. So we have 2 squared minus 4 into 1 into 5. So the answer is negative 16. Beautiful. Remember, after finding the delta, you put it under the square root. If you put that under the square root, we know what's going to happen. If you put negative 16, oh, so undefined. So now what do we say about the roots? We just say the roots are non-real. Why are we saying they are non-real? Simply because, check here, your delta is less than 0. Remember, something that is less than 0 is negative. Therefore, that's negative. Here, we said the roots are real and rational if the square root of the discriminant is an exact value. So now, let's go to the next one. So now, we're building information in our heads. We know if the roots are real, delta is greater than 0. If the roots are non-real, delta is less than 0 because of that negative thing. So now let's look at this one. Guys, I want my child. What do we do with this one? Get rid of it to the others, take it to the other side. The reason it's positive because we're transposing 0. Guys, that's my child. That's my child. So now let's identify A, let's identify B, let's identify C. So now, what is our A? Our A is 1 because that's 1. Our B, 4. C, 4. Nice. So now let's go to the discriminant formula. Delta equal B squared minus 4AC. What's your B? That's 4. Minus 4. What's your A? That's 1. What's your C? That's 4. So now delta equal. So now let's go to the. So we have 4 squared minus 4 into 1 into 4. What's the answer? 0. Nice. So now, let's say we factorize this thing. Let's say we solve for x for that thing. I want to show you something. So now, this will be x plus 2. X plus 2 equals 0. So x plus 2 will be 0. And x plus 2 will be 0. And then if you transpose negative 2, if you transpose negative 2. So are you aware you get the same value of x? We say you get 1 root. And these are equal roots. So now what do we say? What do we see here? Delta is equal to 0. So delta is equal to 0 when we have equal roots. This is the third point. And let me highlight, this is applicable in the tangent case. Because remember, if you have a function that's like this, we will have 1 root between the tangent and the straight line because they will touch at one point. There will be time whereby you'll apply this knowledge to find the equation of a tangent or to find the gradient of a tangent. So now let's recap. Delta greater than 0, it's real. If it's a perfect square or its exact value, the square root of discriminant give you exact value, we say it's rational. So now, if delta is negative, that means delta is less than 0, we say the roots are non-real, or we can say the roots are complex. Those who are doing AP Maths, you will relate to this definition. We are saying the roots are complex. And then if you come to this part, if you have the same value of x in the equation, we say the roots are equal. And then how do we know, or how do we tell using the discriminant? If the discriminant is 0, we know we have equal roots. Okay, let's go to the last one. It's better if you do them like in application form, so that you can understand what is going on here. So now this is the last one. So guys, remember, I need my child, and these people don't belong in here. So I need to get rid of them, take them to the other side. So I will have 3x squared. What about the 5? It's positive. If it go to that side, it will be minus 5x. And then the 1, if it go to that side, it will be minus 1 equal 0. Guys, there's my child. Nice. So now let's identify our A, our B, and our C. So what is our A? That's 3. Our B, that's -5. Our C, that's -1. So now let's substitute them into the discriminant formula. That is b squared minus 4ac. Okay, so now what is the value of b? That's -5. You see, I put it in brackets always. Minus 4. What is my a? It's 3. What is my c? It's -1. We put that in our calculator. Okay, we have -5 squared minus 4 into 3 into -1. Oh, I get my answer, which is 37. And then remember what I said. We take the square root of the discriminant. So that's going to be the square root of 37. Now let's go to our calculator. Square root of 37 was the, oh, not 34, 37. Oh, give us decimals. So we get 6,08276253. So now, what is the value of the discriminant? The delta is greater than 0. No problem. This is 37 is greater than 0. So we are allowed to say, yes, the roots are real. But if you put this in your calculator, you don't get a perfect number like for this one. We put 196 in the calculator, we got 14 exact value. But for this, and we said the roots are rational. And then for this one, yes, delta is 37, which is positive, which is greater than 0, no problem. The roots are real. But if you put this in a calculator, you get some decimals there which are somewhat don't know. So what do we say about the roots? The roots are real and irrational. So guys, that was my 2 cents presentation on nature of the roots. Basically, I'm going to make a note. Therefore, the note, we did it. We did that. Let's look at the first one. If delta, this is number 1, but if delta is greater than 0 and a perfect square. What do we say about the roots? Greater than 0, a perfect square. We say the roots are rational. So in equation, if they say the roots are rational, just know that you are going to put delta greater than 0. That's where you start. Point number 2. Let's come here. Delta was less than 0 here. And then what did we say about the roots? Okay, delta less than 0. What did we say about the roots? We said the roots are non-real or complex or imaginary. So now the roots are non-real, complex, or imaginary. So in equation, if they say the roots are non-real or the roots are imaginary, you will start with this. If they say the roots are rational in a statement, you will start with this. So now number 3. Here, what did we say if delta is 0? If delta is 0, what did we say? We have equal roots. So in equation, if they talk about equal roots, you need to start by writing this. This will be your guide. And then number 4. Oh, here's number 4. It's here. Now, delta was greater than 0, but it was not a perfect square. So here, can you say delta was greater than 0 and not a perfect square? What did we say about it? We said the roots are real and irrational. Important. So now these are the points that you need to make arguments with. If a question says the roots are real or rational, okay, let me add point number 5. If they are saying the roots are real, if the roots are real, delta is greater than 0. This is just for addition. So now let's go through them. If delta is greater than 0 and it's a perfect square, numbers like 9, 36, 25, if delta is 29, 20, 36 or 25, we say the roots are rational, and that is delta greater than 0. So roots are non-real, complex, or imaginary. That's when delta is equal to numbers like -1, -2, -x. Let me say -x. X will represent all the numbers, all the real numbers. And then if the roots are equal, delta is 0. If delta is greater than 0, look at the two, this one and that one. They are just opposite. Both delta is greater than 0, but the other one, delta is a perfect square. The other one, delta is not a perfect square. So if you know this one, you simultaneously know this one. And then the last one, for real, delta greater than 0. So now this is very, very important. So now I'm going to give you a guide on how do you solve equations involving nature of the roots. it's not difficult to solve questions involving nature of roots. Believe me, it's not difficult. So now the first point, remember we have okay, let me call these points let me call them arguments. I'll just do something like this and write argument. So I don't know if I'll be able to. Okay, let me write here. So here, so all these 5 points, I will call them arguments. So now, solving solving questions involving nature of the roots. The first one is to identify the argument. So if the question says, show that the roots are real or the roots are equal, so the argument in the first step, you'll just highlight delta is 0 if they say the roots are equal, delta is less than 0 if the roots are non-real, delta greater than 0 if the roots are real or rational or irrational. You identify the argument. That's the first thing. Now the second thing, get the standard form. Ax squared plus bx plus c equals 0. Getting the standard form, sometimes it's by transposing. That's the first one. Let's make an example. What do I mean if I say by transposing? Suppose you have x squared plus let's say 2x is equals to let's say x plus 2. So you can just transpose, so it will be x squared. Let's use k here. Remember, by transposing, I need my child here, so we transpose, so it's going to be plus 2x minus x minus k equals 0. So that will be x squared plus x minus k equals 0. So getting the standard form sometimes possible through 2 cases. The first one is by transposing, and then the second one is by factoring by x. So I'm factorizing by x. Like let's say you have x squared plus 2x is equals to kx plus k minus 1. So now, since we know all the rubbish need to leave so that we can see the child, which is 0. So we have x squared plus 2x minus kx minus k plus 1 equal 0. So once we see 0, we get happy. We are happy. So now, factorizing by x, do you see we have common factors there? Common factor of x. So we can factorize by x. So if you factorize by x, we will have 2 minus k, and then I'll prefer using plus and then put the whole thing in the bracket. Okay, that is negative k plus 1. I think this is also important. Use plus and then put everything in the bracket. So now we have the standard form. There's the standard form. It's either by transposing or by factorizing. And now the last part, you denote. To denote is just to identify. Denote A, B, C, and sub into delta equal b squared minus 4ac and solve. Let's see from these examples. So if, let's say we are dealing with this one, so if you compare this with ax squared plus bx plus c equals 0, what is your a here? Your a is 1. What is your b? It's also 1. What is your c? It's negative k. So here a is 1, b is 1, c is negative k. So on this one, what is your a there? Your a is 1. What is your b? Remember, b is associated with x, so we can, this thing is the same as, is the same as 2 minus k into x. So that means this one here, it's our b, because from the standard formula ax squared plus bx plus c equals 0, anything that is associated with x, it's our b, even if it's on the other side. So here our b will be 2 minus x, 2 minus k, and then our c will be the entire constant, so that will be negative k plus 1. You see why I used the plus sign there. So, and then after denoting a, b, c, you substitute into the equation and then manipulate and solve. And then the last step, I think, will be, the last point I think will be to conclude on what you found